Hello, honors algebra students. Mr. Lawrence here, and we're going to learn a new way to solve quadratics called completing the square. Yeah, you know how to do it by factoring, and sometimes you can treat them like a linear situation when b is 0, but we're going to learn a new technique called completing the square. Before we do, I want to review the perfect square trinomial. Remember the perfect square trinomial? This is what I showed you before Thanksgiving. Some of you have opted not to use it, but it's really such a simple thing, and you are honor students. I really expect you to pick it up. When the first term, this x squared term, is a perfect square, if I take the square root, I get 3x, right? And the c term is a perfect square. Take the square root, I get 7. Now, if I multiply those two together, I get 21x. And if I double it, and I get b, I've got a perfect square trinomial. This factors quite simply. I'll get two quantities, still equal to 0. I put the square root of the 9x squared in the lead in both quantities. I put the 7 in the back in both quantities, and then decide on what sides. Hey, Disha, if there's a plus in the back, it's the Wendy's double stack. The negative shows up twice. With a perfect square trinomial, it'll always be the same quantity twice, okay? Now, if you're Colin Peretti, you're a little bit lazy and you'd like to write this instead of writing the same quantity twice. It's the same answer. It's totally acceptable. It's a good kind of lazy. All right. So, and then, of course, I'd have to solve it. I would write 3x minus 7 equals 0. I wouldn't waste my time writing it twice because it's the same thing. I'd add 7 to both sides. And I'll get 3x equals 7, then I'll get x alone, and x will equal 7/3, or 2 1/3, right? Okay, and that means if I put 2 1/3 in for x into the original equation, I will get 0 out. So let's see how to complete the square. Now notice that this one here, this green problem, yikes, it's moving apart on me. It's already a perfect square trinomial. Yeah, did you notice that? Now, normally it won't be, but for this one, I decided to make it a perfect square trinomial to begin with. So I take the square root of that, and here I'm just checking to make sure it's a perfect square trinomial. 3 times x is 3x. Do I double 3x and get the b term? I do. Very good. So it's a perfect square trinomial. So it's going to factor like x plus 3, and I'm going to write it the lazy way. Now, some of you are like, well, what should I do? Well, let's undo the exponent. Yeah, let's get rid of the exponent by taking the root. Now, many of you last week, Laura Miles included, saw me pretend to get upset when you told me the square root of 25 was 5. Remember, all positive numbers have 2 square roots. So the square root of 25 is plus or minus 5. I really have 2 equations here. Yeah, I have the equation x plus 3 equals 5, and I also have the equation x plus 3 equals negative 5. I need to solve those 2 equations. You see that plus or minus 5 there? All right, so negative subtract 3, and I'll get x equals 2. And here I'll subtract 3, and I'll get x equals negative 8. And so my solution set would be 2 and negative 8. And there you go. So if I put 2 into the expression in for x, I'll get 25 out. And if I put, wait, that doesn't seem right. There's 1690, 25, there we go. Okay, and then if I put negative 8 in, I'm going to get 25. And you can verify that if you like. All right, I think you'll get a negative 25 with a negative 8. Yeah, I think so. Anyway, all right, so let's go down here to some practice problems. Now, these on the left-hand side are not perfect square trinomials, but I'm going to show you how to make them perfect square trinomials. First thing I'm going to get rid of the c term. I'm going to subtract 6 off of it. Okay, and then I'm going to be left with x squared plus 4x plus blank. We're going to fill in that blank in a second. All right. Now, to make this a perfect square trinomial, what number do I need here? Some of you might have just figured it out on your own, but here's what I'm going to do. I'm going to take half of the b term, not with the x, just the b term, and I'm going to square it. So half of that is going to be 2, and squared is going to be 4. Okay, so what I have here is x squared, oops, on the fat pen by mistake, plus 2x plus 4. But if I add 4 to the left-hand side, I also have to add 4 to the right-hand side. Did you catch that? This middle term here, I took half of it and squared it, wrote it there. But if I add 4 to one side, I have to add 4 to the other. So this is really on the right-hand side. It is really 9. Now I have a perfect square trinomial. Okay, so this is going to factor as x plus 2 quantity squared, and that's going to equal 9. I'm going to take the square root of both sides, and I'll get x plus 2 equals 3, and x plus 2 equals negative 3, because remember the square root of 9 is plus or minus 3. I'll solve both for x, and I'll get x equal to 1 and x equal to negative 5. All right, so it's called completing the square. I'm forcing the expression to become a perfect square trinomial. All right, let's look at a couple more examples here. It's really not that difficult. You just kind of have to memorize the process. Okay, so first thing I'm going to do is I'm going to get rid of the 1. And I'm going to have an x squared plus a 6x plus a blank. And I'll tell you what, let's do this. We'll have a 32, but let's put plus a blank on the other side. We'll be consistent. If I do it to one side, I have to do it the other. And then that way when I fill this in, you'll know to fill that in. Okay, so let's take half of 6, which is 3. 3 squared is 9. 9, all right. So now I have a perfect square trinomial. It's going to be x plus 3 quantity squared. Did you notice that this number is the half of b number every single time? Yeah, and 41. Now I'm going to take the square root of both sides. Okay, and some of you are thinking, wait a minute, there's no square root of 41. Well, yeah, I know it's an irrational number. So I'm going to get x plus 3 equals the square root of 41. And x plus 3 is going to equal the negative of the square root of 41. I'm not going to touch my calculator. I am not going for a decimal here. Colin, put the calculator down. We don't want a decimal. It's an irrational number. And so we're going to subtract 3 from both sides. And since 3 is a rational number and square root of 41 is irrational, they're not like terms. So I'm going to have negative 3 plus the square root of 41. And here, I'm going to do the same thing. But again, they're not like terms. So I will get negative 3 minus the square root of 41. Now, if you're lazy, you could have written it this way, negative 3 plus or minus the square root of 41. You'll see me start to do that more often if there's an irrational number in the problem. All right, let's try 2 more here. And don't worry, we're going to get lots of practice with this tomorrow. Okay, so we got to get rid of the 20, right? Add 20 to both sides. So I'm going to have x squared plus 3x plus blank equals 20 plus blank. All right, now, some of you are going to go half of 3 and you're going to go 1.5. That makes it so hard. Let's think about half of 3 as 3 over 2. And then when I square it, I'm going to get 9/4, right? Okay, so 9/4. Okay, and here I'm going to have to write a 9/4. And then this should be a perfect square trinomial. Yeah, watch. The square root of that is going to be x. The square root of that is going to be 3 over 2. Well, if I multiply them together, I get 3 over 2x doubled. Wouldn't the 2's cancel out, leaving me a 3x? See that? So I get x plus 3 over 2 quantity squared equals, now if you want, you can change that to a mixed number. What's that going to be, 2 1/4? So that'll be 22 1/4 if you want to do that. There's nothing wrong with that. You're going to find I go back and forth between fraction, decimal, and improper fractions a lot, depending on whichever one is easier. So now I take the square root of both sides. Okay, and I'll get x plus 3 over 2, and that's going to equal the square root of 22, and that's going to be an irrational number. That's not a perfect square. I can always double check on my calculator, but I should, if I do it, I'm going to get a big, long, ugly decimal. As a rule, I don't want you touching your calculators on the square root ones, unless you're just checking to see if it is a perfect square. Yeah, I got this big, long, ugly decimal. It's going to be irrational. So I'm going to have, oh, that's plus or minus, right? Okay. So x is going to equal negative 3 over 2 plus or minus the square root of 22 and a quarter. And it's kind of unusual to leave that as an improper fraction when that's in a decimal form. So I might actually go ahead and go negative 1.5. And it might seem like I'm being inconsistent or changing the rules, but there's some things about radicals you don't know yet. We're going to get to after Christmas break. When you know those things, we won't have to do that. Okay? All right, so let's try this one here, and then we'll be done. There's no video quiz on this yet. I'm just trying to give myself more room to work here. Okay, you can disregard this problem. Whoops, that's the problem we just did. Okay, so this problem here, first of all, I subtract 4 from both sides, right? And so now I have x squared minus 4x plus blank equals negative 1 plus blank. All right, I take half of that as negative 2. I square it to get positive 4. All right, it's a perfect square trinomial now. I'm going to get x minus 2 quantity squared. How do I know? Well, it's negative because b is negative, and that number is half of b. As long as I get this part right, this is simple. Okay, that'll equal 3. Take the square root of both sides, and I'll get x minus 2 equals plus or minus the square root of 3. All right, going to add 2. Add 2. They're not like terms because one number is rational, the 2, and one number is irrational, the square root of 3. So I have 2 plus or minus the square root of 3, and that's perfectly acceptable to give your answer that way. All right, I don't expect you to have mastered this, but after a little practice in class, I expect you to be really good with it. All right, Mr. Laurence signing off. Have a good night, everybody.